Hello and welcome guys. This is the lecture number on limits, right? So today we'll discuss about what is limits of a function and what is neighborhood of a function, and after that we will solve some of the problems of limits, and then we'll learn about right hand limit, left hand limits, and lot of things, right? So this lecture is all about the basics of limit of a function, right? So this is the lecture number on. So let's start the video by showing you the first presentation. uh, so wait a second please. Yeah, so here you can see that before starting the topic, which is limit, let me first give you some of the questions so that you can understand what a function, what is the value of a function, how actually functions should look like, and all these things. So the question is, suppose if you have a function fx which is equals to x square, then find the value of f of 2, f of 1, f of minus 1, and f of 5. So can you find the value of f of 2, right? So here you can see that the function is given to you, which is fx equals to x square, right? So in here, instead of x we have to put x equals to 2, right? So if we put x equals to 2, then the value will be 4, right? Similarly, for the case of f of 1, it will be 1 square, I mean it will be 1, right? So for f of minus 1, it will be minus 1 whole square, which is equals to 1. And similarly, f of minus 5 will become minus 5 whole square, which is equals to 25, right? So you guys already know that how to find out a value of a function at a particular point, right? Here the points are basically 2, 1, minus 1, and minus 5, right? So you can easily find out the value. Am I right or not, right? So we are just putting the value x equals to 2, x equals to 1, x equals to minus 1, and x equals to minus 5, right? So that we can find out easily these values, right? So let me first try to motivate you that how the limit should look like. Suppose the function which is fx equals to x square is given to you, and I'm just drawing the graph of fx equals to x square, which is almost looks like that, right? So if I just put x equals to 2, suppose x equals to 2 is there, right? So for the case of x equals to 2, we'll get the value fx. Suppose this is fx and this is actually x, right? So the fx value will become 2 also, right? So similarly, so if we put x equals to suppose 2.00000001, right? It is very close to 0 or close to 2, right? So can you tell me what will be the value of fx? It is almost equals to 2, right? Equals to 4, right? Because we are just substituting the value of x, which is very near about 2, right? So which is 2.00000001, right? So similarly, fx equals to x square will become something around 4.00001 or something like that. Yeah. So if we put x equals to 1.999999, right? It is also very close to 2, right? So can you tell me what will be the value of fx? It is basically very close to 4, right? It is very close to 4, right? So in this particular video, or in this particular video of lecture of limits, we're just trying to understand what is x tends to some particular value or something, right? So here you can see basically limit of a function would look like something like that, right? Limit x tends to 2x square, right? So what is this actually? You have to first post-mortem all these things so that you will be able to understand what am I actually trying to express, that what is limit of something, right? So just wait a second. Yeah, so first of all you have to notice that here three terms are there. First is limit, lim, right? It may be sometimes written as in the books LT. It may be sometimes written as LIM, right? So you may choose any one of them, but this is the most usable formation of limit, right? So limit is basically looking like LIM, okay? And second term is x tends to 2, right? And the third is the function, which is fx, right? Fx equals to x square. So there are three terms are given, and we have to understand each and every terms sequentially, right? So what is limit actually? So basically limit is a kind of probabilistic thing. I mean, it is not a probabilistic thing, but you may understand that what will be the limit of this particular thing, right? First of all, suppose fx equals to x square graph is there, right? And suppose x tends to 2 means what? Basically, what type of closed value of 2 you can think about it, that is actually x tends to 2 means. I mean, if you choose x equals to 2.000001, right, so that is very close to 2. Some of the students will say, sir, we can choose more zeros after the after this, and it is also close to 2. Some of the students will say, sir, we can choose 1.999999999, right? It is also close to 2, right? So you cannot say like what will be the very close, what will be the value, what will be the constant term which is very close to 2. We're just assuming that, or we can say that this particular value is close to that, but this is actually infinite. There are a lot of infinite values which is close to 2, right? It may be on the left side, it may be on the right side. I mean, suppose you have a real line, and suppose 2 is there, right? So basically 2.0000 something is very right side of 2, right? Because it will be 2.000001 or something, right? Similarly, 1.99 is very close to 2, which is on the left side of 2, right? So x tends to 2 means there are two possibilities will come, right? Let me clear that part so that let me take another page also. That will be something like, yeah, right. We have x tends to 2, right? So if we draw a straight if we draw a real line, then to somewhere around there, then 2.00001 will be something on the right side of 2 and very close to 2, right? Similarly, 1.9999 something is left side of 2 and very close to 2, right? So basically, limit x tends to 2 implies two varieties of limit, two varieties of things. One is x tends to 2 plus, another is x tends to 2 minus, right? X tends to 2 means there are two things will you can say. One is x tends to 2 plus, another is x tends to 2 minus, right? So what does it mean, like x tends to 2 plus? It means that x is actually greater than 2, right? But the difference between these two values, which is 2 plus minus 2, is not very much. It may be somewhere like equal, very near about 0, right? I mean, we can choose x tends to 2 plus as x equals to something, right, like 2.000000000 and 1,000,001, right? We can choose that particular number, which is almost near to 2, but it is not equals to 2, right? That means x tends to 2 plus. Similarly, what will be the value of x tends to 5 plus? It is very near about 5, but it is actually slightly greater than 5, right? So similarly, you can say what is x tends to 2 minus? X tends to 2 minus is, I mean, it will be almost around 1.9999 1,000,099, right? This is also very close to 2, and it is slightly lower than 2, right? This is actually the meaning of x tends to 2 plus and x tends to 2 minus. So generally we are just taking x tends to a. A is a particular point or a real number, right? So there are two possibilities will come. One is x tends to a plus and another is x tends to a minus, right? So x tends to a plus means a value which is very close to a, but it is slightly greater than a. Similarly, x tends to a minus means it is very close to a, but slightly less than a, right? So that is the actual, basic fundamental thing of x tends to a. So let's move to the previous slide. So actually you guys understand that what actually x tends to 2 means, right? X tends to 2 means. Similarly, here the function will give you, right? Will be there, like it is x square, it may be like it is x square, it may be x cube, it may be 1 minus x, it may be 1 by x or anything, right? It may be sine x, it may be cos x, like so. So basically the total things means is actually limit x tends to 2, x square equals to 2 square. So here you can see that the value of x is not equals to 2, but instead of thinking about the nearest value of x, like 2.0000 something or 1.9999 something, in order to find out the value of the limit, we don't need to think about the right side or the left side of that particular particular constant term or the particular tending value. We have to substitute the value on the limit if it is differentiable function. First of all, let me clear one thing. If it is differentiable function, we'll discuss it on the further lecture, but you have to understand the basic fundamental thing, which is if limit is extending to 2 x square, we have to substitute the value of x, which is 2, on that particular given function. So it will be 2 square, I mean it will be 4, right? So limit extends to 2 x square equals to 4 means the value of x square, the value of x square, I mean the given function, the value of the given function tends to 4 as x tends to 2. What does it mean? Let me understand by showing you some graph, right? By showing you a graph. Wait a second, please. Yeah, yeah. So basically, suppose you have a graph which is y equals to x square, right? It is almost looking like that. So it is y equals to x square. Suppose x equals to 2 is there, right? So x equals to 2 is there. So can you tell me what will be the value of y? It will be almost 4, right? So what does it mean? If we choose any particular value near about 2, then the value of fx, I mean y, will be near about 4, right? So as x tends to 2, the value of y, I mean fx equals to x square will tends to 4, right? So it is not equals to 4, it is almost near about 4, right? So you have to understand that. But in order to write the exact value of the limit, you have to use the symbol which is equals to, right? So limit x tends to 2 x square equals to 4 means the value of x square tends to 4 as x tends to 2. Similarly, can you tell me what will be the meaning of limit x tends to 0 x square? It is nothing but 0 square, I mean 0. So the value of the given function, which is x square, tends to 0 as x tends to 0. Similarly, if we have limit x tends to suppose 5x square, right? 5 and x square is the given function. So it will be 25. So x square will tend to 25 as x tends to 5, right? It is also called the limiting value of x square as x tends to 5. So you can understand the basic things about limit, right? Here three types of fundamental things are there. One is lim, I mean limit, and second thing is x or any variable which tends to a constant number, which may be 2, which may be 0, any not only any constant number, but sometimes you will see that it maybe tends to infinite or minus infinite, right? And there will be a function for which we have to find out the limit of this particular function, right? Okay, let's move to the next slide, which is answers of limit. Before starting the all these things, that how can I find out uh, the value of a limit which has very difficult type of functions? How can I apply all these things? Before starting this topic, let me talk about what are the answers of limit, what you will get. It may be any real number. Like here in the previous slide, you can see that we can get any real number like 0. We can get any real number like 25, like 0, like 4 or something, right? So answers of a limit may be real number, right? Maybe a real number, I mean L is a real number which always belongs to minus infinity to infinity. That shows that L is a real number, right? L is a real number. So we may get any real number, I mean as a value of a limit, as an answer of the limit. We may get infinite, right? It is infinite or infinity, right? Infinity or infinite, right? Yeah. We may get negative infinity. It is positive infinity, it is negative infinity, right? Infinity. we may get that the value of the limit doesn't exist. The value of the limit doesn't exist. We will discuss it in a further lecture, but before that, you have to understand that there are mainly four types of result you can get from a limit. One, that the value of the limit is either a real number or infinity or minus infinity or doesn't exist. So there are four types of value you can get from a limit, right? Okay, let's move to the point which is neighborhood of a point. I have already discussed what is neighborhood of a point. So before starting the topic which is neighborhood of a point, let me talk about a very interesting thing, which is, suppose this is your house, right? This is not a circle. This is not looks like it is not your house, I understand. But suppose this is your house, right? And there are some roads actually past, passing, from your house. And there are some locality around your house, right? There are some locality around your house. So you may have neighbors, right? So what is actually neighbors? Neighbors means those people who have who is actually very close to your house, right? It's living very close to your house. Similarly, neighborhood of a point means, suppose this is a real line and you have a point which is, suppose you can choose 5 as a point. The neighborhood of a point means the very closest value of 5. It may be 5.00000001, it may be 5.2, it may be 5.3, it may be 6, it may be 5.1 million 01, it may be 4.99999, right? It may be 4, it may be 4.2, right? So these are the values which is actually neighborhood of 5. I mean very closest value of 5, right? I have already discussed. So these are actually neighborhoods of a point. So you can understand, suppose you have a as a point on the real line. Suppose this is a point which is a, then neighborhood of a point is actually the closest value of a, which are actually called the neighborhood of a, right? In a mathematical language, suppose you have a point which is delta, which is greater than 0, but delta is very small value, right? Very small value, or delta is very close close to 0, but not equals to 0, I mean, we have a number which is very close to 0 but not equals to 0. It may be 0.00000005, right? Or 1. Then the open interval, which is a minus delta comma a plus delta, is called the neighborhood of the point, which is a. It may be written as n delta of a. I mean delta neighborhood of a, right? So which is the open interval of a minus delta to a plus delta. Suppose you have a value of delta which is equals to, suppose, 0.00000001. Then the neighborhood of the point a, I mean the delta neighborhood of the point a, is nothing but a minus 0.0000, that guy, comma a plus that guy, which is 0.0000 something. Similarly, if we actually choose delta as 0.5, then the delta neighborhood of a will be a minus 0.5 comma a plus 0.5. So neighborhood of a point is basically a open interval, open set, or open interval, basically an open interval which contains some of the points which is near to this particular value, or you can say that to this particular point. I mean, if you have 2 as a point, then the neighborhood of the point will be somewhere around 2 minus delta comma 2 plus delta, right? This is called the delta neighborhood of the point. You can arbitrarily choose delta which is obviously close to 0 but not equals to 0. So these are the actually points which is neighborhood of a point, right? So let's move to the definition of a limit. So actually, what is the definition? What is the general definition of limit? This is actually discussed in this particular slide. Let me zoom in this particular thing so that you can easily you can see, right? So the definition of a limit says let a function f be defined at every point, in the neighborhood of a. I mean, if you have a function which is f, that must be defined in the neighborhood of the given point a, right? That may be defined. That may be defined means it has a value or it exists on the neighborhood of a. I mean, this is an open interval about a. I have already discussed that neighborhood of a point is an open interval, right? Except possibly at a. I mean, you have to choose those values of, those values in the neighborhood of a, except possibly at a. You can choose a also, there is no issue, right? But you have to, try to, neglect the particular value which is a. You have to think about the, values which is very near to a, right? So if a, as x approaches closer and closer to a, I mean, it may be on the right side, maybe on the left side. I mean, x may be 2 point, suppose x may be a plus very, some positive value. It may be a minus some positive value. So it is very close to a, and that x, I mean the given variable which is x approaches to closer and closer to a, but not equals to a. This is a very important line. We don't have to take the value of x as a. It is very close to a, right? Then the value of the function which is fx approaches a real number L. So if x approaches to a, then the given function which is fx approaches to another real number which is L. Then the number which is L is referred to as the limit of the function fx as x tends to a, and we write it as limit x tends to a fx which is equals to L. So you can understand, as fx tends to L, x tends to a. I mean, fx will be tending to the value L, tending to the real number L as x tends to a. So again, I have to read all the limit, read about the definition of the limit, which is let a function f be defined at every point in the neighborhood of a, which is an open interval about a, except possibly at a, if as x approaches to closer a but not equals to a, then the value of the function which is fx approaches a real number L, right? Then the number L is referred to as the limit of fx as x tends to a, and we write it as limit x tends to a fx equals to L. This is actually L, right? You have to understand this is actually L, right? So you can understand the definition of a limit, right? Right. So let's move to some methods, right? So these the method, right? In this particular lecture, we'll learn about almost, three methods, at least three methods, which will be the in the next slide. But this is the first method. Before solving any kind of limit, you have to first check whether the substitution method will work or not, right? First, you have to check about the substitution method, right? You have to check the substitution method. What the substitution method says, I have already discussed about the substitution method also, right? I didn't rename it, but suppose limit x tends to 2, x square is there. So what we actually did, we just put the value of x which is equals to 2, right? So it will be 2 square, I mean 4. Similarly, in this particular slide or these problems, we have to just substitute the limit. We have to just substitute the value of x, right? Here you can see x tending to 1, right? So we have to substitute the value of x which is equals to 1 on the particular given function. So if you substitute the value of x which is 1 on the given function, so it will give us 3 times 1 minus 1, right? So it will be 3 minus 1, I mean 2, right? So the limiting value of that particular function is nothing but 2. Similarly, for the second problem, we have to substitute the value of x. Here you can see x is tending towards minus 2, right? We don't need to think about the near value of minus 2, right, in order to solve the problem. It may be an analytical part in the theory section, but in order to solve a problem, you can substitute the value of the given variable, which is x, right? So here x tending to minus 2. So we have to put x equals to 2 on the given function. So it will be minus 2 upon 3 times minus 2 plus 5, right? It will be minus 4 upon minus 6 plus 5. It will be minus 1. So it will be 4. So the value of the limit will be 4, right? Similarly, for the next example, here it is given that t tends to 0. I mean, we have to put the value of t as 0, right? So if you put the value of t as 0, so it will be 0 square plus 3 times 0, right, minus 5. So it will be 0 plus 0 minus 5, right, which will be 5 only, right? So you can see what is substitution method. In this particular method, this is actually the method which we will always check at first, right, before solving the limit, that whether we can substitute the value or not, right? If we substitute the value of x on the given function, and we will get some of the form like 0 by 0, infinite by infinite, 0 to the power 0, and 1 to the power infinite, these types of values which has no values in real number, right? Then we will move further methods also, right? So this is the method which is called the substitution method. In this particular method, we have to substitute the value of the given function, right? Of the given variable. It may be x tends to 1, it may be x tends to 5, it may be x tends to minus 2, it may be t tends to 0, whatever it may be the value, right? Let's move to the factorization method. Why factorization method? In this method, we will learn that if we substitute the value of x, right, given particular value, then that particular function will not give you any real number. That particular function will not give you any real number. Let me check. If you put x equals to 3 on the numerator, it will give you 3 square, I mean 9, right? Let me check. 9 minus 3 times 4, it will be 12 plus 3. On the denominator, it will be 3 square, it is 9, minus 5 times 3 will be 15 plus 6. So numerator will be minus 3 plus 3 will be 0, and the denominator will be minus 6 plus 6, 0. So you know, right, 0 by 0 is actually undefined, right? It is not belong to the real number, right? It is not belong to a real number. So you can say that this limit value doesn't exist, but that is not the true. You have to, what I told you is you have to first check whether the substitution method work or not. After substituting the variable, the value of the variable, if you will get the type of values which are 0 by 0 or infinite by infinite or 0 by infinite or infinite by 0 or 1 to the power 0 or 0 to the power 0, any type of value like that, then you should not use the substitution method again, right? I mean, this method will not work. Then we may have to use other methods. So in this particular slide, we'll learn about what is substitution method is, right? What is substitution method is basically, sorry, factorization method. So basically factorization method means we have to factorize the given function, right, on a two part. So here we have already learned about what is quadratic equation, right? So limit x tends to 3. I'm just writing this as it is, and the numerator can be written as x minus 3 times x minus 1, right? We can write down the numerator as x minus 3 times x minus 1. I mean, we are just factorizing the polynomial which is x square minus 4x plus 3 as x minus 3 times x minus 1, and on the denominator we can factorize that particular polynomial as x minus 3 times x minus 2, right? So you can see that that will be again form like x square minus 5x plus 6, right? So here you can see x minus 3 and x minus 3 are actually same, so we can actually neglect that part, and you have to write down on the right side that since x tends to 3, since x tends to 3, okay, therefore x is not equals to 3, so therefore x minus 3 is not equals to 0. What that means, right? This is actually since, this is therefore, right? The symbols of very mathematical tools. So what we did actually, right, suppose if that part is equals to 0, then we can't cancel that part, right? Can you tell me what is the value of 0 times 2 upon 0 times 5? It has no value, right? It will be 0 upon 0, right? But we can't cancel that 0 and 0 because we can cancel only non-zero values. So some students will say that since x equals to 3, then after substituting the value of x, which is 3, the numerator will become 0, that part will become 0, that part will become 0. So we can't cancel a part which is equals to 0, right? That should be non-zero, then we can cancel. So then you have to think about the fundamental or the analytical part of limits. Basically here x tends to 3 means x is not equals to 3. If x is not equals to 3, then what will be the value of x minus 3? Here I have already write down that since x tends to 3, therefore x is not equals to 3. If x is not equals to 3, then definitely x minus 3 is not equals to 0. I mean that part and that part is not equals to 0. So if it is not, since it is not equals to 0, so we can neglect that part. So what we will have limit x tends to 3, the numerator will be x minus 1 and the denominator will be x minus 2. So now you can see that we can substitute the value, and the part that the function will not give me any kind of value which are of the form 0 by 0 or infinite by infinite or these types of form, right? Undetermined form. So if you substitute the value, it will be 3 minus 1 and the denominator will become 3 minus 2, right? So it will be 2 upon 1, I mean 2. So you can see that the value of the limit will become 2, right? So limit x tends to 3, x square minus 4x plus 3 upon x square minus 5x plus 6 equals to 2, right? If you substitute the value, it won't work. But if you factorize that particular polynomials, right? Then after cancelling some of the part in the numerator and the denominator, when you substitute the value, you will get a real number, and that is the actual solution, or that is the actual answer of that particular limit. So you have to think like substitution method will not always work. We'll learn about this in the later videos. Let's move to the next question, which is actually limit x tending to 2, x square minus 4 upon x minus 2, right? So again, I have already told you that you have to first use the first method, I mean the substitution method. If substitution method will not work, you have to go to the next method, or you have to go to another methods, right? So first substitute the value, let it will be 2 square minus 4 and the denominator will be 2 minus 2. So here you can see it will be 4 minus 4, I mean 0, and the denominator will be 0. So it is actually the 0 by 0 form. I mean this is actually undetermined form, undeterminate form, right? So this is actually undeterminate form. So that particular thing has no value actually, right? So if it, so substitution method actually didn't work, right? So since substitution method didn't work, you have to go to the another method. So here you can see actually we can use the factorization method in this particular example also, right? So limit extending to 2, you can write down this part as x square minus 4 can be written as 2 square, right? And the denominator will be x minus 2, right? So it will be limit extending to 2, you know, x square minus 2 square can be written as x plus 2 times x minus 2, and the denominator is actually x minus 2. So you can cancel that part, right? We can cancel that part, and we have to write down here as, since x tending to 2, therefore x not equals to 2, therefore x minus 2 is not equals to 0, right? X minus 2 is not equals to 0. Since x minus 2 is not equals to 0, we can cancel this. We have already told you how we can cancel this, right? So the function will become limit x tends to 2, x plus 2. Now we can substitute the value of x, which is 2, right? So it will become 2 plus 2. I mean, the value will be 4, right? So the limiting value of that particular function is actually 4, right? So you can understand what is factorization method. You can say that method is actually the second method, and this is actually you can say as the first method, right? Let's move to the third method, which is called the rationalization method, right? This may be called as third method, right? So this is also similar as the previous part, which is actually you have to first check whether the substitution method will work or not. If the substitutional method will work, then you don't need to think about these methods, right? But if the substitutional method will not work, which will be the general case in the upcoming videos, like in the upcoming videos, you will learn that most of the questions didn't, will not work the substitution method. Like, I mean, the substitution method will not work in those questions, right? Then you have to move to the either the second, which is actually called the which is actually called the factorization method, or the method, right? So you have to think about it, right? So what is rationalization method is actually? So the rationalization method is actually you have to rationalize the part which is actually create some problem, right? So here you can see that this, we can learn about the method by this particular example, which shows you that limit extending to 0, the numerator is actually root under 4 plus x minus root under 4 minus x, and the denominator is 3x, right? So first thing is you have to substitute the value. If you substitute the value, it will become root under 4 plus 0 minus root under 4 minus 0, and the denominator will be 3 times 0, right? Because here x is there, so if you substitute the value of x as 0, so it will become 3 times 0. So the numerator will become root under 4 minus root under 4, and the denominator will be 0, right? 3 times 0 is 0. So you can see that root under 4 minus root under 4 will become 0, and the denominator will be 0. So actually this is actually a form of undeterminate, right? This is actually an undeterminate form. So we should not, or we must not move to the substitution method, right? We don't need to move the substitutional method, right? So let's let us discuss that what is actually factorization method is. Before discussing about that, let me first erase that part. Let me erase that part. So yeah, okay, I think there is some glitch or something happened, but okay, that's no worry. So this particular method will not work, like this particular method will not work, right? This particular method will not work. Let me wait a second, please. uh, Let me wait a second. Like, there are some glitch happened in this particular slide or something. Yeah, sorry for your inconvenience, but yeah. So the substitutional method didn't work, right? Didn't work here. So we have to move to the rationalization method or any factorization method. So we can rationalize them, right? We can rationalize these two parts. So that will be limit x tending to 0. The numerator will become, we have to multiply by root under 4 plus x plus root under 4 minus x. Definitely we have to multiply the denominator also by 4 plus x, which is 4, sorry, what is it? Yeah, 4 plus x plus root under 4 minus x, right? So then you can see that if we cancel that part, it will be the previous one, right? So limit x tending to 0, that part you can see that minus a minus b times a plus b type of form. So it will be a square, I mean root under 4 plus x whole square minus root under 4 minus x whole square, and the denominator will become 3 times x root under 4 plus x plus root under 4 minus x. So it will be limit x tending to 0, root and square will be cancelled out, it will be 4 plus x only, right? Minus limit root and square will be cancelled out, it will be 4 minus x, and the denominator will become 3 times x root under 4 plus x plus root under 4 minus x, right? Yeah, so it will become limit x tending to 0. If I just calculate that part, it will become 4 plus x, or if I just remove that bracket, it will become 4 plus x minus 4 plus x, and the denominator will become 3 times x times 4 plus x plus root under 4 minus x, right? So that 4 and minus 4 will be cancelled out, and you will have limit x tends to 0, 2x, because x plus x will be 2x, and the denominator will become 3x times 4 plus x plus 4 minus x. So here you can see x and x can be cancelled out, because here I'm using that since x tending to 0, therefore x not equals to 0, right? Since x tending to 0, therefore x is not equals to 0, right? Therefore x is not equals to 0. So we can cancel that part related to x, right? So it will become limit x tending to 0, 2 upon 3 times root under 4 plus x plus root under 4 minus x. So now you have to check whether the substitution method is work or not, right? So if we put the value of x as 0, so it will become 2 upon 3 times root under 4 plus 0 plus root under 4 minus 0, right? So it will become 2 upon 3 times root 4, I mean that will be 2 plus root 4, that will be 2, right? So it will be 2 upon 3 times 2 plus 2 will be 4, right? So if we cancelled 2 by 4, it will be only 2, and that will be 1. So it will become 1 upon 6, right? So you can see that particular the value of that particular limit is actually 1 upon 6, right? So this is actually the rationalization method would look like. You have to rationalize the part uh, by this particular rationalization method. You can understand, right? Yeah. So let's move to the next slide, which is called the right hand limit. It is actually a spelled mistake. Like it will be not like that. It will be right. It will be right hand limit, right? Right hand limit. It is not actually not like that. Yeah. So what is right hand limit? Basically, I have already told you that if you have a real axis, which is like that, and if you choose any particular value, suppose this is actually 2, so the right hand part is nothing but that part, right? So a particular value which just closest to 2, but actually little bit greater than 2, I mean 2.000000 something, is called a right hand limit, right? So it has a definition. which is, we say that right hand limit of fx, I mean the given function, as x tends to a is kind of, you can say, the particular value or the constant value exist as it as is and is equal to L1, right? As it equals to L1 if as x approaches to a throughout values greater than a, right? Then the values of fx approaches to definite unique real number L1, and we write limit x tends to a plus fx equals to L1, or f of a plus 0 equals to L1. I mean, first of all, you have to learn that if limit x tends to a, fx is there, then that has two particular thing, right? That has two particular value or something. You can say that one is for the limit x tends to a plus fx, and another is limit x tends to a minus fx, right? If limit x tends to fx exist and if limit x tends to a minus exist, then we can think about the limiting value of fx. That will be another discussion. But this particular thing is called the right hand limit. Right hand limit of fx at x equals to a. And this particular thing is called as left hand limit. Left hand limit of fx at x equals to a. So x tends to a plus means we have to try to find out the value which is closer to a but little bit greater than a. That means x tends to a plus. And x tends to a minus means we have to try to find out the value of a which is actually near about a and closest to a, but it is actually lesser than a. I mean, it just goes to the left side of from the a, and it is right side on the a, right, on the real axis. So we say that right hand limit of fx as x tends to a exists and is equal to L1 if as x approaches a through values greater than a, the values of fx approaches a definite and unique real number L1, and we write limit x tends to a plus fx, I mean the given function, is equals to that particular real number which is L1, or you can say f of a plus 0 which is equals to L1, right? This is actually called the right hand limit. So here is a working rule. Here is the working rule of right hand limit. So this is actually, you can see working rule, right? To evaluate limit x tends to a plus f of x, there are two particular methods is given to you. One is put x equals to a plus h, right? Put x equals to a plus h. This is the working rule. First rule is we have to put x equals to a plus h in fx to get limit h tends to 0, limit h tends to 0 f of a plus h, and take the limit as h tends to 0. I mean, if you have a question which is suppose x tends to a plus fx, right? So first of all, you have to put x equals to a plus h, right? And you have to take the limiting value as h tends to 0, and the function will become a plus h, right? This is called actually the right hand limit, the process of finding the right hand limit, right? Right hand limit. So you can understand we have to just substitute x equals to a plus h, and then the limit will be changing to limit h tends to 0, limit h tends to 0 f of a plus h, right? Okay, so let's move to the move to some questions so that you can think about it more deeply. Here you can see limit x tends to 2 plus. I mean, we have to take the value which is near about 2, closer to 2, but it's little bit greater than 2, right? So you can substitute the value, but you have to use the working rule here, right? So the working rule says you have to first put x equals to a plus h. Here a is nothing but 2, so we have to put x equals to 2 plus h, and taking the limit as limit h tends to 0, right? So it will become limit h tends to 0, and x cube will become 2 plus h whole cube, right? 2 plus h whole cube, right? So let's erase that part. Yeah, so we have to take x equals to 2 plus h, and the limiting value will be limit h tends to 0, 2 plus h whole cube, right? So now you can actually expressing this as a plus b whole cube. It will be a cube, I mean 2 cube, please, plus 3 times 2 square times h, plus 3 times 2 times h square, plus h cube, right? So it will become limit h tends to 0, 2 cube will be 8, plus 3 times 2 square will be 2 square will be 4, 4 times 3 will be 12 h, plus 3 times 2 will be 6 h square, plus it will be h cube, right? So now you can substitute the value of h, which is h tends to 0, I mean h equals to 0. So it will be 8 plus 12 times 0, right? Plus 6 times 0 square plus 0 cube, right? So that total part is equals to 0, and it will be 8 plus 0, I mean 8, right? So the value of this particular right hand limit is actually 8, right? Similarly, let's think about that part. First work is you have to put here you can see that limit h x tends to 0 plus, I mean in the place of a we have 0, right? So we have to put x equals to a plus h, I mean 0 plus h, right? So it will be limit h tends to 0. Let's yeah, right, that's right. Limit h tends to 0, and 1 by, it will be, sorry, it will be 0 plus h, right? It will be 0 plus h, right? So actually this is a problem of it's kind of like the value of this limit will be infinity. Why? Because here first of all we don't need to use that particular term, because here you can see that is 0 is there. So if you substitute the value of x as 0 plus h, which is nothing but x equals to h. So as x tends to 0 plus, then definitely h tends to 0 minus 0 plus, because x equals to h is there. So we can think about only that particular part also. We don't need to think about this thing, right? So if we have limit x tends to 0 plus 1 by x, right? So what does it mean actually? X tends to 0 plus means x has value which is not equals to 0. That is a trivial case. And x has a value which is very closer to 0. I mean 0.0000000, there are 1,000,001, right? So suppose if we choose x equals to 2, then 1 by x will become 1 by 2, which is nothing but 0.5. If we choose x equals to 1, then it will become 1 by 1, I mean 1. If we choose x equals to 0.5, it will be 1 by 0.5, which is nothing but 2. So can you tell me what is the graph of 1 by x? Can you tell me what is the graph of 1 by x? Just wait a second, please. Just wait a second. Can you, sorry. So can you please tell me what is the graph of 1 by x? Basically the graph of 1 by x is almost looking like in the positive term, it is actually almost similar as that. When x is actually positive, right? And when x is actually negative, it will be like wait a second, it is almost similar like that, right? This is actually the graph of 1 by x, right? Am I right or not? Basically, if we put x equals to minus 2, then it will become half, right? That is the graph of 1 by x. This is the part of x less than 0. So x tends to 0 plus means we have to choose a point of x which is near about 0 plus. Suppose at x equals to 1 we have the value of 1 by x, which is 1, right? At x equals to 2 we have 1 by 2. At x equals to 3, so we have 1 by 3, right? I mean at x equals to 3 we have 1 by 3, right? but when I choose x equals to suppose half, then it will be 2. When x equals to 1 by 3, it will be 3. Similarly, when you close to 0, when you're trying to close to 0, I mean very close to 0, then can you tell me what is the value of fx? It is, you can see that it is actually a positive infinity, right? It will not cut the graph actually in general. So it will be very close to actually positive infinity. I mean that part will tending to positive infinity, right? So limit x tends to 0 plus 1 by x will become 1 by x will become positive infinity, right? Because x tends to 0 plus means x equals to 0 point, very, it is actually very close to 0 in a positive term, right? So 1 by x will become positive infinity. Okay, let's erase that part. Let's erase that part. Wait a second, please. I think there is something happened. Okay, let's move to the next question, which is actually limit x tends to 3 plus x square plus 3 upon x plus 2. Since 3 is non-zero, so let x equals to 3 plus h, right? We have to take a plus h, I mean 3 plus h. So the limit will become limit h tends to 0, sorry, h tends to 0. The numerator part will become 3 plus h whole square plus 3, and the denominator part will become 3 plus h plus 2, right? So it will be limit h tends to 0, that part will become 3 square, which is 9, plus 3 times 2 times h, it will be 6h plus h square, right? I mean 2 times 3 times h, it will be 6h plus h square plus 3, right? Plus 3, and the denominator will become 3 plus 2, it will be 5 plus h, right? So limit h tends to 0, that part will become 9 plus 3 will be 12, right? Plus 6h plus h square, and the denominator is 5 plus h. So let's put the value of h as 0. So it will become 12 plus 6 times 0 plus 0 square, and the denominator will become 5 plus 0, which is nothing but 12 upon 5, right? So the value of this particular limit is actually 12 by 5. So now you can understand that how we can calculate the right hand limit, right? So in the upcoming video we'll learn about what is left hand limit, how we can find out the values of left hand limit of a function at a point, right? And then we'll learn about the algebra of limits. There are some algebra of addition, subtraction, multiplication, right? Division, all this type of algebra, we'll learn about it. And after that we'll solve some more interesting problem related to this algebra of limits. And after that we'll learn about the squeeze theorem, which sometimes called as sandwich theorem. And then we'll move to the very interesting topic, which will be the problem solving series. In those series we will solve some of the problems of JEE Mains, JEE Advanced, and some of the problems which came in very advanced exams also, right? So we will solve these problems in the upcoming lectures. Till then, stay tuned with us and try to learn more about these limits, try to learn more about these things, and we'll meet soon. I mean, we'll meet will in the next day. I mean tomorrow. And till then, stay tuned. And thank you for attending this lecture. Thank you.